Hello everyone, good morning. Please let me know if I'm audible.
Morning, sir.
Good morning.
Good morning, sir. Yes, sir.
Good morning, sir.
So we'll start in another 1 or 2 minutes. So I have received the assignment from majority of the people now. Okay, so in case anyone is left, so no more acceptance for the assignment, but thanks to all who already submitted it. Guys, please log into your Databricks notebook and confirm me that you have started the cluster as well. So I hope my screen is visible.
Yes, sir.
Okay. So can anyone tell me what is the agenda for the day?
So machine learning with Spark.
Yes, correct, Abhyan. But before we do the machine learning, there are few remaining concepts that we will look into and will then proceed. But before I go ahead, any question on the Spark system?
So like every time we have to create a new this cluster for our work.
Yes, correct.
But sir, like if I've done any work from in the previous cluster, so I have to access that only, no? Or like to resume my previous work, so I have to open that particular cluster only, and all the all the work will be saved there only, right?
Yes,
Or,
correct. So
or
it shows you the clusters here that you used in the past, and you can start that particular cluster if needed. Definitely your older work will be on that cluster.
Oh.
But because it's a free cluster, so sometimes they even remove your older clusters if you're not using it, right? But it's not a problem, right? Because you are not losing anything. What you are doing, you are uploading some data or you are creating some notebooks, right?
Yes, sir.
So your notebooks will be available. If you go here, your notebooks will never be lost. If you look, all these notebooks I am having, they were used for different clusters. You can use any of these notebooks again. That's not a problem.
So I can reuse this whole old notebooks in another new cluster, right?
Yeah,
Fetch
note.
them.
See, this notebook is already there, but it's saying this notebook is detached. Means there is no cluster attached to it. So cluster is getting started, right? So I will attach that cluster once it's started. This new cluster which is getting started, I'll just attach it.
Okay. Right.
And then the same notebook can be run on the new cluster. So you're not losing anything here.
Yes, sir. Got it. Thank you.
But the data will be lost. If you go to the data section, the data will be lost. Whatever files you have uploaded, no, they will be lost. So you need to upload them again. The files that you uploaded for analysis, they will be lost because files got stored on the cluster only, right?
Yes, sir. So I have to just
Upload that
the-
data again.
yeah.
You have to upload the data again. But notebooks, which is the most important thing, data, because it's a cluster for your personal work, so you can get data again. That's not a big problem because it's data for your work, you are learning only, so you can upload again. The important thing is notebooks. Notebooks should not be lost, and I showed you, right? Notebooks are available, always available in your workspace. Okay, so this cluster is getting started anyways. Now if I go back to the previous class where we were working on Spark, I told you that we worked on RDD and we worked on data frames, right? We did both of these. RDDs, they are used in Spark core, and data frames are used in Spark SQL, right? We saw how to create a RDD using Spark context. Spark context is very important thing. Dot text file, we gave the file path, we were able to create it. How to create a data frame?
SQL contest.
Yeah, someone needs to mute. Sorry. Yeah, here we talked about SQL context. Dot read dot CSV, and I told you few other alternatives also. Dot read dot CSV, dot read dot format, dot load. There were a lot of different variations to this command. Even you can pass the options whether there is a header in the file or not. SQL context itself is derived from the Spark context. Okay, so Spark context is the parent for SQL context. Okay. Then we converted a data frame to a temp table, right? And on that temp table, we were running SQL, right? So we did this. Any doubts in this, anyone? So I hope no doubts. Then I told you there is data sets also, which is slightly, one second. There are data sets also which have the benefits of both RDD and data frames. So what was there that RDD was having some good features, data frames were having some good features. So they created a data set which has the features of both. But as I told you, data sets, they are not available with PySpark. They are available with Scala and Java. That's why you don't need to worry about it. And it's not even that critical to know data sets. So we will focus on data frames. Yes, please. Someone was having a question.
Yes, sir, Shivali.
Yes,
So,
Shivali.
like now we have knowledge of data frames, huh? So we can make use of data frame only in every situation, or there are situations where we have to do RDD.
So first of all, consider it this way that today everyone works on the data frames. That's the first thing. If you get a Spark project or a PySpark project, you prefer directly using data frames. No need to go to RDD first. Okay, no need to go into the RDD. But consider that there is a project which is already built using RDD. They'll ask you to translate it into a data frame project. So for that, you should also know about the RDD and its functions. I told you the transformations and actions, right?
Yes.
So unless you are not aware about the RDD transformations and actions, you won't be able to work on that migration project from RDD to data frame. Okay, Shivali?
Yes, sir. What?
So that's the point. You work on data frames, but if you have a RDD project and you have to migrate to data frames, so it becomes important to work on transformations, actions, and RDDs. Otherwise, anything that you can do in RDD, you can do in data frames also. That's not a problem. Okay. Earlier, there used to be some performance benefits with RDD, as compared to data frames. But now they have tuned it so much that you don't need to worry about it. Data frames are equally fast because RDDs are actually the core, na? So core, if you work on core of any system, that will always be fast, because data frame is a layer on top of RDD only. Consider that data frame is a layer on top of RDD. So if you are working on data frame, it will first maybe talking to some core, Spark core, some sort of RDD layer. It's not getting converted into RDD, but I'm telling you that RDDs were the core, so they were comparatively faster. But now it's not the case. Data frames and data sets are equally faster, so you don't need to worry about that. Okay.
Yes.
And there is one more thing, like Spark was built using Scala, right? So if you do coding in Scala, that will be faster. Okay, or even in Java, because Scala and Java are similar. Scala and Java are two similar programming languages, and Spark was built using Scala programming language. So definitely, if you directly work on Scala, it will be faster as compared to Python. This is one catch, remember. If you work on Scala or Java, it will be faster as compared to when you work on Python, means when you work on PySpark. Because Python program gets translated into Scala program behind the scene. Okay, behind the scene, they get converted into Scala and the Java, because system Spark only understands Scala and Java. It does not understand Python. What I am trying to say, let's say this is a Spark core layer, okay, which was built using Scala. Now what you are doing, you are using something outer layer, which is, say, let's say PySpark. So you are writing all the programs here in the PySpark, but that PySpark program gets translated into Scala program. So that additional translation step is involved whenever you are working on PySpark. So Python program gets translated into Scala program, due to which comparatively it happens in a very milliseconds, microseconds, but at least that level of latency or I should say conversion is there. So all the Python PySpark program gets translated into Scala program. So if you write a Scala program and it takes, say, let's say 10 seconds, a PySpark program for the same work may take 11 seconds. In the worst case, ideally it will also be converted into 10 seconds, but it can take 10 seconds plus some additional translation time. And which utility do that? There is a utility known as Py4j. Py4j means Python for Java. So Py4j is a, you can say, a program, an internal program. You don't do anything here. Py4j is an internal program which converts your Python to Java. It's like converting Python to Java. So Py4j is a utility which converts Python program into Java program. So I hope you're getting this point which I'm trying to tell you. Yes or no?
Yes, sir.
Yes.
So that's why some of the companies still prefer Scala and Java as compared to PySpark because of performance. But 99% of the companies, I'm telling you, they are using PySpark. Why? Because this translation phase now is also improved, and it also don't take much time. Earlier it used to take some time, but now even this conversion has improved. If earlier it used to take 10 milliseconds, now it takes only 1 millisecond. So what I'm saying is even PySpark is now very, very fast. So you don't really need to go to Scala and Java. You don't get any big performance benefit by moving to Scala or Java. PySpark is optimized to a very high level, and still they are working on it. Okay. And Python being the most adopted language today in the field of data analytics, so people are focusing on PySpark. So I told you both the scenarios, comparing Scala Java to Python and comparing an RDD to a data frame. Okay, so these are the things. Let's move ahead. So let's look at the same thing again, which we did in the last class. Yeah. So guys, if you look at, like in the last class, we were talking about two variables, two predefined variables, SC and SQL context. In the last class, we were talking about Spark context, and we were talking about SQL context. These are predefined system variables using which you are doing your work. But let me tell you that SC and SQL context, they were used in Spark version 1. Now we no longer need to use them. We are in Spark version 2. Matlab, the most used version today is Spark version 2, where we use something known as Spark session. So guys, earlier we used to use something known as Spark context and SQL context, right? These two things, the problem with Spark version 1 was you have to maintain two different variables, one for RDD, one for data frame, right? Like Spark context separately, SQL context separately. With Spark version 2, they say no need to use Spark context and SQL context separately. I'll give you a single variable, system variable known as a Spark session. So guys, with someone if asks you in interview difference between Spark version 1 and version 2, this is the biggest difference. In Spark version 2, now we use Spark session. So let's see that. So going forward, we will all be working on Spark session. There is another variable known as Spark. Just run that. See, there is a Spark session. If you see, please do that guys once. So difference between Spark 1 and Spark 2 is, in Spark 1 you used to have Spark context. In Spark version 2, we use Spark session. There are a lot of benefits with Spark session. We'll talk about it, but yeah, please check and confirm that this another variable is there or not. See, this variable is known as Spark here, but in your company where you go, this Spark session variable may have a name as SPK. It can have any name. I hope you guys don't get confused that this should always be Spark. It's just a variable name which is pointing to Spark session. Are you getting my point? What I'm trying to say is how this variable was created, maybe something like that. Yeah. So this is the syntax to create a Spark variable, the Spark session variable, using this Spark session class. Spark session is a class. Using that class, I am creating a variable Spark. in this notebook, it is already created. I'm not doing anything. I'm just saying using this particular function or method, it was created by the Spark system automatically for me. But tomorrow this name can be even ABC also. I hope you're getting my point. It's not mandatory that this should be Spark because you're working in Spark. No. This can be anything. So you need to talk to your team lead. Hey, what is the variable for Spark session? But first you will try with the word Spark, because 99% of the time Spark keyword is there. This particular variable name for Spark session, like SC was there for Spark context and SQL context was there for SQL context. But tomorrow these can also have another different values in your company, because these are just variables. I hope you're getting my point, guys. Don't get confused that this should always be SC, this should always be SQL context, and this should always be Spark. These are just variable names. Yes, no. Are you getting my point?
Yes,
Yes, sir.
Okay.
But then alias names.
Yeah. And Madhu, you were asking me how to kill a job, right? I hope I told you how to kill a job. It's like Hadoop job hyphen kill and then the job ID.
In Spark, sir.
Spark, that's a different thing. We'll talk about that.
Okay.
Yeah. Yes. So what Madhu is asking is, like, if there is a Spark job which is running for longer duration and he wants to kill it, so there are different ways of killing that also, different commands. We'll see that later. Using different ways we can do. Okay. So now, guys, what I'm telling you is, going forward, we will not be working on SQL context or Spark context. We will be working on Spark session. So with Spark 2.0 and even with Spark 3.0, everywhere we are using Spark, which is Spark session. And here you see the good news is it is backward compatible. What I mean to say backward compatible, Spark session also provides you Spark context and SQL context. Means even if someone say, no, I don't want to use a Spark session, you are good to use SQL context and SQL context and Spark context. But that is not recommended. So what I'm saying is, in the last class also, we were using the same cluster, but we still used Spark context and SQL context. In the last class also, we were using the latest Spark version, but it does not stop you from using the Spark context and the SQL context, right? That is known as backward compatibility. That we can still use Spark context and SQL context even though Spark session is also available. Getting my point? This is backward compatibility, that yes, you can use the SQL context and Spark context.
okay, sir.
No, are you getting my point? Because otherwise, so you should say, Rahul, that we should only use a Spark session. Why you are using SQL context and Spark context here? Because that's a backward compatibility and that is already available. So if someone is not familiar with the Spark session, he can still use a Spark context and SQL context, but that is not a good thing. Okay. So going forward, what you should use Spark session. Okay, let's go to cluster once. So this is your cluster, no? Imarticus cluster. If you see which version of Spark you are using, guys, can anyone tell me?
3.11.
3.1. So because of backward compatibility, it gives you Spark 2 and Spark 1 features also. means you can use SQL context and Spark context also. But if let's say this would have been Spark 1 instead of Spark 3, if it would have been only Spark 1, so you can only use Spark context and SQL context. You cannot use that Spark session because Spark session was introduced in Spark 2 onwards, like Spark 2, Spark 3 and all. Are you getting my point? In Spark 1, you can only use this two. In Spark 2, you can use this also, plus because of backward compatibility, you can use this also.
So this Spark session is only for Hive, or it can be used for data frames and like RDD?
Everything. We will see that.
Okay. Like
We
how
will
we can
see.
differentiate between this? Like there we can differentiate with SC and SQL context, but here how we can
That's
differentiate?
what they have done. They have combined them into a single. You don't need to maintain two separate entities or variables. They have given you one single variable. We'll see how to use that.
Okay.
Guys, am I audible? Ketiki, I think my audio is fine. Guys, am I audible?
Yes, sir. Yes.
Yes, sir.
Ketiki, is it better for you now? Ketiki, I'm pinging you. Hello, Ketiki. Am I audible? Ketiki, you can disconnect and connect in case you're still facing problem. I have pinged you. Okay, so I pinged her. She'll connect. Anyways, okay. So whenever you are working in any company today, they are using Spark 2 or higher version only. Okay, so that means you will be having the facility to use whatever you want. Whether you want to use SQL context, Spark context, Spark session, whatever. So let's see what we can do. So in the last class, guys, you were using what you were using? You were using Spark context and SQL context, right? But today what we are going to talk about is Spark session, right? This is another variable. So as I was answering Shivali's question also, that today everyone works on data frames, right? So Spark session is used to create data frames. Spark sessions does not recommend creating RDDs. So you cannot create an RDD using a Spark session. Spark session in that way replaces nothing but SQL context. So what I'm trying to say is in Spark 2.0, in Spark 2.0, we have something known as a Spark session, and Spark session variable is used to create only data frames. Now we are just sort of decommissioning RDDs. Hey, no need to use RDDs. So Spark session variable is only for RDDs. Oh, sorry, only for data frames. So RDDs are now not recommended to be used, only data frames. So if this was a Spark 1.0, let's say if this was Spark 1.0, you can have RDDs and data frames. But in Spark 2.0, everything is a data frame. So SQL context is getting replaced by Spark session. So whatever you are doing here, you can do here. Like this, Spark session.read.csv. So, and you can create a data frame. So in Spark 2.0, we don't create RDDs. We only create data frames using Spark session. Everything is same. Instead of SQL context, we are just using Spark context. Sorry, Spark session. So instead of SQL context, now we will be using Spark session. but this thing is gone now. We don't need to use this. But because there is a backward compatibility, I told you there is a backward compatibility, and someone still is very adamant that yes, I want to use Spark 2.0, but I still want to use RDDs. So since there is backward compatibility, we have this function which was there is still available here also. You can do this. So what I'm saying again, in Spark 2.0, we have Spark session, and Spark session can only create data frames. Okay, that means they replaces SQL context. But if someone still wants to use RDDs, you still need to go to Spark context. Because of backward compatibility, it is available, as I told you. But it is, again, I'm saying RDDs are not recommended. That's why I was answering Shivali also that today people don't use RDDs. That's why in Spark 2.0, they are even saying not to use RDDs. But if still you want, you have to go to Spark context only. But it's not recommended now to use RDDs. It's not recommended to use SQL context and Spark context because of some problems with them. They see Spark context and SQL context, they were not that good in terms of memory management and thread management. Spark session, it's not just a variable, it's a completely new class, Java class that they have written, which do better memory management, better thread management. It improves the performance, overall performance of your system. So someone of you may ask, Rahul, to create data frame when SQL context was already there, then why you are using Spark session? Because Spark session is far better than SQL context in fields like memory management, thread management. It improves the overall system performance. So better not to create a data frame using SQL context. Otherwise, if you create a data frame using SQL context as compared to Spark session data frame will be better in terms of memory management, thread management, and a lot of other aspects. So even though both are Spark data frames, the way they get created is more optimized when you use Spark session as compared to SQL context. Are you getting my point?
Yes, sir. Yes, sir.
Yes.
So if you are working on Spark 2.0, always use data frames, always use Spark session. Don't use SQL context. And unless it is very, very needed, don't even go to RDD. Because for RDD, you have to again go to Spark context. So ideally, don't even use RDD. But in some companies, what happened was, let me show you here. In some companies, what happened was, they were on Spark 1.0. They were using only RDD. But now Spark 2.0 came and every company want to upgrade. So in the urgency to move from Spark 1.0 to Spark 2.0, they moved their RDD code from here to here. So what I am trying to tell you is, even in some companies, you will see that even though they are using Spark 2.0, they are using RDDs. Why? Because they just migrated their older code to the newer version of Spark. But they didn't took care that while they were migrating, they should have also translated their RDDs into data frames. They should have done that. You would have converted an RDD project into a data frame project. But that's what I'm saying, that if you go to a company and you will see, hey, they are using Spark 2.0, and you will see, Arey, Rahul told that Spark 2.0, we should use only data frames, right? But you will see that they're using RDD and you'll say what Rahul told is different. So I am telling you what they must have done. They have upgraded their Spark version, but they didn't want it to modify their code. They didn't have that much time or bandwidth or engineers who can convert the RDDs into data frames. That's why you will see some people are still using RDDs on even Spark 3 also. Because they are just keep on upgrading their Spark versions. They don't have time to convert their code, because this code may be 1,000 line of code. Let's say they have 1,000 lines of program written in RDD. They don't have time and resources or maybe knowledge to convert RDDs into data frame, because you have to, if it's a 1,000 line program, maybe around 200 lines will get impacted. I'm just telling you. If you convert an RDD program to data frame, maybe 200 lines of programs can get impacted, or it may happen that 800 lines of programs get impacted. So you have to convert those 800 lines from RDD to data frame. I'm just throwing these terms, this numbers, but just telling you. I hope you're getting my point. If in today's world still you see someone on Spark 3.0 with RDD, that's not a big deal, because they're just keep on upgrading their Spark versions. They're not changing their code. Guys, getting my point? Yes or no?
Yes, sir.
Okay. So if you go to a company which is on Spark 3.0 and still using RDD, but you can say, let me convert this RDD code into data frame now. You can do that. You will get a lot of benefits and ease of use also, right? We are seeing that data frames are very easy to work on. And there are a lot of other benefits. They have schema. It's very tabular kind of structure. Okay. So again, I'm telling you, in Spark 2.0, we should not use SQL context, right? So what we should use? We should use Spark session, which is Spark variable. That's it. You only need to change this. That's the fun. Even if you have to migrate to, even if in your company they say, no, we should no longer use a SQL context. Okay, just change this word everywhere in your code. Wherever you are using SQL context, change it to Spark session. That variable name for Spark session, here it's a Spark, and the code will run as is. You don't need to do any change. Let me run this. See, the code is running. The Spark job is running, right? Everything is running fine. There is no problem. Definitely, it is getting this file already available, so it's able to read that file. Guys, are you getting my point? I didn't change anything. I just changed SQL context to Spark session. The file was already there. Huh? So all of you, please try it. Wherever you were using SQL context in the last notebook, please check if it is working. I was just trying to give some other file name and see if, so it failed, right? That part does not exist, because I was just trying to see and show you that this file is already available in the cluster. This is a bit strange that this file is still somewhere. I didn't uploaded it again, but and I'm working on a new cluster, but somehow that file is still available. Maybe it got linked. Okay, because my cluster name is same. I think that's why it might have the older cluster and new cluster name is same, so it might have linked this file. But for you, this may fail, and you have to upload file again. Please try it, guys.
No, sir, it's working.
It's working. It's fine.
I have changed my cluster name. It's
So some,
also working.
It's working, sir.
yeah, somewhere it's having this file globally stored, but in real world it should fail. Okay. In this particular case, what might be happening is there must be some common global storage where this file might have been loaded, and the cluster is able to read it from there. Because you remember I told you that Spark does not have any storage. So whenever you are starting a new Spark cluster, you are starting only the processing layer. The storage layer is still something provided by the cloud. So that file was somewhere in the cloud and it is accessing that file from somewhere. Are you getting my point? Because this file must be loaded in some other storage space of this Databricks. In Spark, storage and processing are two different things, right? Whereas in Hadoop, HDFS and MapReduce are tightly coupled. Spark, whenever you are starting a cluster, you are starting a computation cluster. Its storage cluster, which is this path, it is separately managed in Spark. Right? Spark does not have a storage layer, right? Spark can even use HDFS also for its storage, right?
Yes, sir.
So that's why this path might be accessible, but what I am telling you, ideally this file should have been uploaded again. But because of the separation of the things and you using cloud, there is not a problem. System is handling that internally. But no problem, even if let's say it fails, then you just go to data section and upload it again. Right? That's what I want to tell you. Even if this fails, saying part does not exist, you go and upload that file again. Not a big deal. But it's running for all of you.
Yes, sir.
So there is no difference now. You can work on those data frames as is. If you want to see the data, you want to convert that into a temp table, everything can be done. You convert it into a temp table and you run the query. Right? So everything is working fine. But let's say there was a Spark context also, correct? There was Spark context also. Let's try to replace this also with Spark session and see if this runs. That means if this runs, ABC will be created as what? Guys, RDD or data frame?
Data frames.
The data frame.
No. Text file.
Read CSV.
Text file is a function that creates what? RDD.
RDD.
Yeah.
So if this function runs, it will get you RDD. So please check it. This function is not available in Spark session. So what I'm trying to tell you is using Spark, you cannot create an RDD. Spark session object has no attribute text file. Because text file function was used by whom? By Spark context to create an RDD. So if you say, no, I want to create RDD, you have to go to Spark context only. And because of backward compatibility, yes, it is available. And if you see what is ABC, so ABC is an RDD. Okay. So what I'm trying to say is Spark session does not have text file function because it's a RDD function. We use another function of Spark context, which is parallelize, which was to create an array into a RDD. So let's convert this also into Spark. Now using Spark session, you are using a parallelize function to create an RDD. Let's see this. Spark session has no attribute parallelize. That means Spark session does not support any of those functions which were used to create RDD. For all of those, you need to go to what? Spark context. So whenever you have to create RDD, you have to use Spark context only. These functions are not supported by Spark session. Spark session only supports those functions which were used by SQL context to read a file. Any kind of these functions, all of these are supported by Spark. Any question? Guys, any question? Okay. So I hope you are getting my point that for RDDs, what you have, for data frames, you have two options, either SQL context or Spark session. But we should use Spark session because of a lot of memory management and thread benefits. Okay. So that's it. You have a data frame. Like there are two ways of creating a data frame, either using SQL context or Spark session. Read about it, read more about Spark session. That what are the benefits of Spark session, memory benefits, and a lot of other optimization benefits of Spark session. Then we converted a data frame into a table. And then we were able to run SQL queries. To convert a data frame into a table, there are other one more function available. Data frame dot create or replace temp view. Let's give its name as football. Okay, and then here you can select star from football. So guys, one second. So what I'm trying to tell you is, you worked on RDDs, you worked on data frames using two ways, SQL context and Spark session. Then you convert a data frame into a table. So there are two functions. One is register temp table. This is actually older function. This function was used in Spark 1.0. With Spark 2.0, they are given a new function. But again, backward compatibility, both are available. Create or replace temp view, football, and then again. So you can say it's like a view or a table, but these are both temporary tables, whether FIFA or football. These temporary tables will be available only till the session. Once your session is off, these tables will be gone. Yes, please tell me the question.
Yes, sir. Where is showing, sir, uploaded data? Means a table.
What? Repeat.
Where is showing uploaded table? Means a data table. Means in my code, it's showing there is a path does not exist. File store table
At
and
this level?
file. Yeah.
Were you there in the last class?
No, sir.
So that's what the problem is, no? If you're not in the last class, you haven't uploaded this file. But how you got this notebook then?
Yeah, sir. I uploaded using means this file I'm taking from Google. Kaggle dataset HIPAA 20 layers 20.csv
Okay,
and
wait.
uploaded on.
Share your screen.
Okay.
Are you sharing?
Yes, sir. 1 minute. There is a slow internet, that's why it's taking time.
So Pratik is taking longer than expected. Let's move ahead. Huh?
No, sir. No, sir. It's worse.
What?
Yes, sir. It's done. It's done. Almost done. Uh,
Go to the notebook. Where is the notebook?
yes, sir. Yes, sir. It's advanced sharing.
Yes. So wait.
Here.
Wait. No. Show me this only. Data frame is this dot read dot format option load this. Does this part does not exist? Okay. Yes. Go to the data section. Go to the data left hand side. Yeah. Okay. Create table. Click on the upload section. Yeah. Where is that file? It was at the top. It was at
No,
the
sir.
top.
It's
It is at.
I
Uh,
extracted this one, so it's fast.
no problem. Okay, wait. Let it done. Do one thing, please cancel this. Don't you
I
have?
did same procedure.
No. Wait. Don't you have any shorter file,
Cancel.
a smaller file? Cancel this,
Okay.
please. Cancel this. It will take too much time. Now upload any other file. Any other smaller file that you have. Yeah. Upload this.
Yes,
Now
sir. It's done.
click now below. Click below. There is a yes. Create table with UI. Scroll down. Click. Select the cluster. Select the cluster.
Yes, sir. Preview table.
Preview table. Yes. Scroll down. It's done. Scroll down. Let it done. Wait. Have you done all these steps?
Yes, sir.
No problem. And do you have header in the first line? Yes. So on the left hand side, click that first row is header. On the left hand side, left below. First row is header.
Yeah.
That's it. Create table. It's done.
Oh,
Go ignore this error. It's done. Go back to that notebook. Yeah.
Notebook. Okay.
Workspace. Uh, change the name of the file, students performance, right? That was students performance.
Yes, sir.
Students. I think capital S and capital P. Capital S.
I will check, sir. Student. Oh, yes, right.
No, capital S. I don't know, some problem is happening with your system, but this is the process. Just go on to the left hand side. No, go back to that notebook. Yeah, data. Go to the data. Yeah. It's showing. Nah? Click on this. What's happening? Click on this. No, don't delete. Click. It's uploaded. That's not the problem. Go back. Go back to that notebook. Instead of file name, just put a star there. I think you might be missing something. Hey, it's capital F and capital S. No, in file store it's capital F and capital S. I think you didn't copy the path correctly, huh? It's capital F and capital
Yeah,
S.
sorry, sir.
Yeah. Now run it.
Yes, it's running, sir.
Yeah, now you can go ahead. Huh? Okay.
Yes, sir.
Please
Thank you
stop.
so much, sir.
Welcome. Please stop sharing. So I hope you all understood how to create tables, like how to convert a data frame into table. This is another function. Let me ping you. Please have it. Sorry, I introduced a comma. So sorry, a quote. But before you do that, there is one more thing I want to tell all of you. Guys, I told you that when you have to run SQL, you have to use this percentage SQL, right? But that is not always possible. You cannot. Sometimes what happens is when you will say percentage SQL now, this is a magic word. This magic word may not be supported by your Jupyter notebook. It happens. Let's say even if you try to do this on your Anaconda notebooks, it will fail. That it does not understand what this is. Let's say it is something like that. It's, for example, it's saying invalid syntax or something, right? What I'm trying to say is sometimes these kinds of errors will come. That the magic function, percentage magic function, whatever that was, is not found. Then what will you do? Then you won't be able to run SQL. If that percentage SQL magic word is not understood by your notebook, then to solve that problem, we have another way. In Spark session dot SQL, yeah, you are doing all these things, right? Just cut it all and say Spark dot SQL within brackets, within double quotes, put this. Okay, what this will do, this will create a data frame for you, and then say data frame dot show. I'll come to this, but let's see. This is another way of doing it. So let me put this parallelly. So guys, see, ideally you should always use this, but when this magic word is not understood by your notebook, it's fine. Ideally, this is the then way to go ahead. You are saying, hey, Spark session, please run a SQL query. It will say, okay, tell me what is the SQL query. So the same SQL query you can put inside this, and instead of %SQL, you can write spark.sql. But here you will not get the output immediately because it will create a data frame and you have to say data frame.show. Or else you can do this also. Function chaining. This is one function, this is another function. Functional programming. So either you first create a data frame and then say data frame.show, or you just simply run this command and at the end of it say .show. So please run these commands. I am pinging you all. Please practice them. So to run a SQL query in PySpark, you have this, and this three ways. Okay. Please do it and confirm me. And as I told you, you already had SQL context. Even SQL context also supports this. So try even with Spark session or SQL context and confirm me. So I'll give you 5 minutes. Please practice this function, all these things, SQL context. Please do that. I'll be back in 5 minutes. Please practice this. So guys, any question, anyone? Is it working fine?
Yes,
Guys,
sir.
anyone, any question? Am I audible?
Yes, sir.
Yeah,
Yes,
I am
sir.
saying, are you getting how to convert a data frame into tables? What are the two functions? So it's all about functions. You have to just remember these functions. And how to run SQL queries. So using Spark session.sql or SQL context.sql. And there are multiple ways of doing this kind of work. You can do it like this also. First create a data frame and then data frame.show. Like we say rdd.collect. Here we don't have collect function, we have show function. Or you can use this function also. But the good thing about this, the output is quite good. The output is in a very tabular format, but above the output was not that tabular. But though it's also tabular, but look wise it's not that good. With this magic word, it is becoming better. So if no questions, we can move ahead. Guys, I'm waiting. Any question? Okay. So before I move ahead, we talked about RDD, we talked about data frame, we talked about sort of temp tables, and then we ran the SQL. All these things are done. Temporary views or temporary tables, whatever, how to create them, right? So here something very interesting comes into picture, that we converted a data frame into a table, right? But can I convert an RDD into a data frame? Yes. What you can do, let's say you are given an RDD, you can convert an RDD into a data frame also. Remember, I was telling you migration projects where company will ask you to convert a RDD project into data frame project. You can convert an RDD into data frame. After that, everything will be the way you have been doing. Convert data frame into table and run SQLs on it. But this is the biggest challenge, converting an RDD into a data frame. Okay. So there are multiple ways of doing it. How to convert an RDD into data frame. We are not doing it, but let me explain you, because this is not needed, otherwise I would have told you, but let's go into this. Go into the Spark, okay, Apache Spark. This is my GitHub account, as I told you. What we want to do, we want to convert an RDD into a data frame. See, if someone say you to convert RDD into data frame, first of all, what is the problem? The problem is RDD does not have a schema. Remember? And data frame needs a schema. Means an RDD will not know its column names and data types. But for data frame, it is mandatory. So that's the problem. So converting an RDD into a data frame, there are three ways of doing it. Something known as row class. We have to understood about some classes, like we have classes and objects, right? There is a class known as row class. There is something known as a case class, and then we have something known as struct type and struct field. So there are three ways in which you can convert an RDD into a data frame. Okay, using a row class, case class, or struct method, using struct types and struct fields. So let me just ping you first before we talk about it. I'm just looking at that code. 1 minute. Okay, I'm not getting it, so I'll tell you from the internet. Guys, if you see my screen, see what it will be telling you, the three methods is, first of all, this row class. There is a row class method that we can use. There is this struct type method and struct field method. I'll quickly try to show you these methods. Yeah, so here it will make sense. Huh? See, no one wants to work on RDDs, right? No one wants to work on RDDs. Everyone wants to work on data frames. But how to create a data frame, right? So creating a data frame is also very easy, I told you. But what if someone say, hey, I have a RDD. Can you convert that RDD into a data frame and then do all the work? Then you will say, hey, the problem is that RDD don't have a schema, means you don't have the column names. That's the biggest challenge. So let's see this. What I did, I have an RDD here, guys. I'm using an array, a simple Python array, and using sc.parallelize, I converted that array into RDD. I have an RDD. Now I need to convert this RDD into a data frame. So let's see how to do it. First of all, you want to see the data of RDD. So let's see the data of an RDD. These are, remember I told you RDD have some actions and transformations. Collect is one of the way to see its data. So these are all rows of an RDD, around 12, 13 rows of an RDD. If I want, there is a count function. 15, there are 15 data elements. So these 15 elements, can you imagine this like one column? Can you imagine that this is like a table with only one column? And let's say this is employee ID. Let's consider that. Let's consider these are the employee IDs of 15 people. So what you are trying to achieve is, you are trying to convert an RDD into a data frame, means you are converting into a table with one single column. converting this RDD into a data frame is like having a table with one single column, having values as 1, 2, 3, whatever these values are, 55, 667. Are you getting my point first of all before I go into the next step? Guys, yes or no?
Yes, sir.
Why you want to convert RDD into data frame? So that once you have this data frame kind of structure, you can run any SQL on it, right? Like I want to ask you the maximum employee ID. So select the max of the employee ID from this table. You can easily do all these things, right, on a data frame. But if I ask you to do the same thing on RDD, you have to use those map functions, flat map functions. Remember in the last class we were doing map function, filter function. That becomes comparatively complex. So everyone today wants to convert an RDD into data frame, but this RDD does not have any schema, but data frame needs schema, means the column name. Do you have column name in RDD? No, you don't have the column name, whether the column name is ID or whatever. So that's what I am saying, that converting an RDD into data frame is not a big deal, but the problem is there is no schema. So we need to create a schema first. Let's see. All of you now understood what we are trying to achieve. So these are all the different ways of doing it. Row class, case class is not here, struct type and all. I'll go by a simple method. This val, remember I told you val means this is Scala program. So I'm not using Scala here. I'll convert it into Python. So you don't need to worry about what is this val. This is Scala program. I'm converting it for you easily. So just remove the val, that's it. हाँ. So guys, देखो, there are multiple ways of doing it. I am telling you what I am telling you is I should say the easiest way. Okay, let me tell you the easiest way. You say Spark session. Here this Spark is Spark session. Create a data frame for me. This is another function. So it tell me the RDD. Which RDD? Here RDD is RDD. Let's say it's R1. Just to remove any confusions. Your RDD name is R1. So this RDD R1, you want to convert it into a data frame. So, but you have to give a schema, and you don't have any schema, right? So that's the problem. So what I can do, I can pass a schema here like something like this. Let's see, ID. The column name is ID, and let's see if it works. Parsing exception, like we come in Java, there is this exception. That data type and all. See what's saying, hey, that schema does not contain the data type. You will understand it in future, but data type is missing. I told the column name, but I didn't told the data type. Let's say it's what it's a string. Let's say it's a string. Okay, it's an int. So there is some problem. So I'll solve it, but one by one. So what you are saying is, Spark, please create a data frame. Converting an RDD into data frame, you need a schema. So this is one of the way to specify schema, but system does not understand it, the column name and the data type. So let's remove it. Instead, what we need to use is struct type and the struct field, which I was telling you just now. Let's remove val again. Put this everywhere. Okay, I'll come to this. I'll explain you this. So what I'm trying to tell you here is that whenever you want to convert an RDD into a data frame, you need to attach a schema. The simplest way that comes to everyone's mind is, okay, there is only ID column, let's say ID, and let's say the data type int, right? But system does not understand this syntax. Rather, we have to create schema properly. So this is how we create schema. In schema, what we do, we create a structure. A schema is like a structure, the column names and the data type. So for our RDD, how many columns it has? Only one column. So for each column, you will keep adding a struct field. For example, in this structure type, means in this schema, I want to add first field, I want to add second field, I want to add third field. If you have three fields, like say employee ID, employee age, employee gender, in case you have RDD with so many columns, and you are also saying the data type, hey, ID should be string data type. True means whether null should be allowed or not. True for whether nulls are allowed or not. Double type, int type, like this is how we create a schema. And then this schema variable, we simply pass on here. That's it. So before I rectify this code and run it, are you getting what I'm trying to explain? Converting an RDD into a data frame, but the biggest challenge is always the schema. So you just need to create schema. So please ping me. Are you able to understand this or not?
Yes, sir.
Adhyan, Arushi, Yukti, Shivali.
Yes, sir.
So if anyone asks you to convert an RDD into a data frame, because you don't want to work on RDDs, you don't know all the functions for RDD, you can convert that RDD into data frame easily. Okay, but this is the function. Hey Spark, please create a data frame from this RDD. So Spark will say, give me the schema. And specifying schema here is not like you just keep passing the column names like you do in SQL. You have to create a structure, proper schema structure. So this is struct type, which is having struct fields. So if you look here, this is what one of the way I was telling you, struct type and struct fields. Now it must be making sense to you. Struct types and struct field. You will create a struct type which internally contains all the fields. In our case, it's only one single column, right? So remove all of these and that's it. We are done. So this is the way you are creating a schema, a new struct type, adding a struct field into it. But the problem is, guys, these functions, struct type, struct field, they are not available by default. These are special functions. So we have to import them. We need to import these functions, okay? Here it is. I'll tell you.
In case we have to create it 50 and 60 columns, then what we will do?
Go one by one. Wait. Okay. So see what this program will become lengthy. Okay. So we'll see what you are trying to do. This is the function that is waiting for you to give it a schema, and this is how you put on a schema using a struct type and a struct field, right? So you need to import these functions. So from PySpark.sql.types, like data types, you are importing struct types, which contains struct fields, right? And the string type. Even if you want to use double type, like double, okay. So first of all, you need to import these data types. Okay. So there are slight syntactical difference between Java and Python. So I'm just modifying it according to the need. Okay, I'll come to that in a while. So what you need to do, first of all, you need to have a schema. So that schema will be created like you have a structure type which contains only one struct field. Its name is ID. Okay, its name is ID. It's of the double type. Nulls are allowed or not, true or false. Schema is ready. I simply pass that schema into this create data frame function, and it's done. This df is done. Let's see. This data frame is created now. This data frame is created. That this data frame contain a column ID of the type double. Nullable is equal to true. So let me explain you again. You are saying, hey Spark, please create a data frame for me. That means using this RDD. So it will ask you, tell me all the columns that RDD contains. So you have to create a schema object. How you will create a schema object is using struct types and struct field. You are saying a struct type. Struct type is a global value, global keyword. Internally, it contains only one struct field, one column. Every field it's like a struct field. Column name, columns data type, and whether it allows nulls or not. Okay. But these functions you definitely need to import, right? Like you import from scalar, import linear regression, logistic regression, like that. So we are importing it. That's it. And you will see our data frame is created, and we can see its data. Okay. If someone say, what if I have multiple columns? If you have multiple columns, yeah, if you have 50 columns, you have to write 50 columns here. So, but this is just a one-time activity. Once an RDD is converted into data frame, you will get a lot of benefits, right? Who was asking? Bala, Madhu?
Others.
Yeah. So are you getting my point? So like this, you have to keep adding the columns and tell their data types, string type, like that. You have to keep doing this. Means whatever are the columns and their data types, whatever. Let's say department ID. So what I'm telling you guys is there are 3 ways of doing this, like this schema and all. The best way, the oldest way is this only, using struct types and struct fields. So we create a struct type which contains all the struct fields. Struct is nothing but structure. You are defining a table structure, schema. So it's consider these as columns, right? Names, data types, whether they allow nulls or not. Once you have the schema ready, you simply pass that schema into this function and that's done. Let's say if I do this. No, sorry. If now this is new schema which I attach to this RDD, right? See, now you got the new schema. But when I will try to read this data, see, Spark is lazy. Spark is lazy means currently it told you, okay, for this RDD, this is the schema, but RDD actually contains only one column. So it only will load the first column, rest will be null. Rest will be null or blanks. So we are attached a schema, bigger schema. Guys, getting my point? Yes or no?
Yes, sir.
So let me first tell you this. I'm pinging you. Please run it step by step. First, you need from PySpark. This is a PySpark package, Python package. You need to import these functions. Then you need to create a schema first. Once you have the schema, you simply apply it to your RDD, whatever RDD you have, and just see if you're able to run all these commands. Please confirm me once it's done. Okay, to keep it simple, let me also ping you this. If you don't have this, how to create RDD, those of you who are not in that class, I have pinged you. First run the RDD creation command, then create a schema for that RDD, and then attach RDD with the schema in this step. Okay, Shivali, I'm waiting for a few more people. Shivali, for you, if it's done, please try to see the data using df.show. It will fail. There is some error which I'm looking into. And if you see Py4j, I told Python for Java, there is some Py4j error here. Everything is working fine, but when I'm trying to see the data, it's not showing me, which is like not a big deal, means some error is happening, which we can check. Guys, please confirm me if it is working for you.
Yes, sir, there's an error in df.show.
That is fine. Why? Because if you look into the errors logs, it's saying the struct type cannot accept the object one. So the first value when it was going, uh, it's coming as an object, and it's somehow class int. So it's not able to pass that value one into the int column. So I hope you're getting my point that the first structure type, that the schema that you created, it started to assign the values inside it, but somehow the values are not getting loaded. There is some compatibility issue between the values. So let me check. First, cut it down only to a single column because we don't have multiple columns in our data. Check your schema, okay? Whenever you check the schema, structure type, it's a list of strings. It's a string type, okay? So it's a string type. Nullable true. Okay. Okay, we can check that later, but I hope you are getting my point that how to create a schema and how to attach a schema to a data frame. Okay. This is what we normally do. The problem is happening in the data. The data is not compatible. Okay. So I'm just checking. So go into the PySpark's documentation. For the time being, I'm just trying to change this data to a string data and see if get low data. Let's say so I have two string columns. This is my string and the double type. Let's make it string type. And let's try to run this with schema is this. Schema. Okay, we'll check that in the next class, what's happening here. But just for your knowledge, I'll tell you, if you go into the logs, the error that's coming here is the Python error, and it's a type error. That struct type here, see, Rahul, when it's going into the string class, right, this value is not considered as a string value, rather it's considered as an object. It's an object. So what's happening is I am trying to assign an object Rahul into string, which is the problem. So this Rahul should have been converted into a string first. So I need to check why it's happening, why this value is being taken as an object, because unless it remains as an object, it will not go into string. Okay, so this needs to be done by a typecasting. I need to handle the type data type. That's why you're getting this type error or the data type error. Okay. In case anyone else get to solve it, please do let me know. And you see worker.py, this is like the worker node. Spark's worker node is trying to analyze this particular scenario and is trying to run this program on a worker node in a Spark worker node. Okay. So this is one of the way. Some minor thing we are missing, we'll check later. Okay, any question before we move ahead? Everyone is getting this error, please, at least that will tell me that you have run till this place.
Yes, sir.
Okay. Okay, let's do one thing. Guys, take a break. Take a 15 minutes break. And once we are back, I will have the solution also ready for this. And then we will go into the machine learning. So we'll be back at 1:20. I'll solve it by then.
Okay.
So please be back at 120. I'm solving it. So it is working, like in case people are back, so it's resolved. I'll tell you what I did. Harish, you are there?
Yes, sir.
Okay, so in case you get disconnected because of this battery thing, no problem. Let me tell you the solution then. Huh?
Okay, sir.
So then I'll repeat it for the others as well.
Okay.
So if you see, we are doing a very simple thing. Then that okay, we have an RDD. We need to convert it into data frame. Okay, very important. So you
Yes,
always
sir.
need a schema. because RDD never have schema, right?
Yes, yes, sir.
So it's all about creating the schema which we saw using struct type and struct field, right?
Yes, sir.
That in the structure type you keep adding all the struct fields. Whatever fields you have, you keep adding here, right?
Yes, sir.
That's it. And then we were able to run everything was running perfectly fine, but data was not getting displayed, correct?
Yes, sir.
So let's see, 1 second. One second. Yeah. So if you see now the output is coming. Okay. So what I did, I said Spark session dot create data frame. This is the RDD. This is the schema. It got attached. We
Yes, sir.
can see the schema, and even I'm able to see the data. So data is also coming. But
Yes, sir.
what was the problem earlier? For that, we have to go to RDD. Okay, let's go to RDD.
Okay, sir.
So, yeah. So let me show you what I have done. So this was my original RDD having the value of Rahul and Ajay. But now I have created another RDD, which is also having values as Rahul and Ajay. But if you see, they are within some internal brackets.
Yes, sir. Yes, sir.
Yeah. So what was happening, guys, was that this entire value was getting mapped to my columns, as in if this was the data frame with this was the column. So ideally this should be a separate value and this should be a separate value, right? This is separate row and this is separate row, right? But in this particular scenario, both of these, they were going as is, and system was not able to handle it. Why? Because if both of these values will go to the system to a column, then it is like a full list is going. And a list is nothing but an object. So what was happening earlier was that this entire data, means the full list, was going inside that particular column, and it was failing because column was of the type string and you are trying to load list into it. So system was not able to understand it. So what I had to do, I had to convert it into this form. I'll tell you how. So that when this particular record will go, it will be this only this Rahul value, not the Ajay value, because that is another list. So earlier both of these values were combined together. I have to segregate them. I have to segregate them into a separate row, you can say, or a separate element. So this is always to be done. And how to do that is using the map function. Okay. So using the map function, we always needs to do this. 1 second, I'm getting a call. Yes or not? Hi guys, sorry, got a call. So what I am trying to tell you is, whenever you are given an RDD, just look at the data of an RDD, and if the data is in this particular format, that RDD cannot be converted into a data frame. You first need to convert it into this kind of format, okay, where each element becomes a separate list. Earlier it was a complete list. You have to convert each element into a separate list using this map function, which we did last time as well. So if you look at what we did last time, like if you look at last time, we had entire file that we read, which was having this first row, this was the second row. But if you see, the problem here is the first row is an element of a list, like a bigger list. Second row is also part of a bigger list. So what we did was we splitted this data. We splitted this data to get it into the desired format. So always make sure that an RDD in this form cannot be converted into a data frame. We first need to use a map function to convert it into this form, and then it will be done. So what I want all of you to do is, whatever RDD you had, use that RDD, create a map function on it to get a new RDD, and then use this R2 for conversion to data frame. So I'm pinging you this method. Please try it and tell me if it works. Remember, as a rule of thumb, your RDD should never be in this format. It should always be in this format to do any advanced analytics or conversion to data frames, anything. Madhu, Harish, please do it and confirm.
Yes, sir. It's done now.
It's working.
Yes, sir.
And there is another logical concept if you think about. If you look at this, this is what? This is a one-dimensional array. If you look at this is a two-dimensional array. What is a table? A table is always a two-dimensional object, right? A table is always a two-dimensional object where it is having rows and columns. So those of you who know about matrix, so it's something like a matrix in Python, where it's like the first entry, the second entry. So it becomes a two-dimensional array. So every table is a two-dimensional array. So that's why we have to convert it, RDD, into a two-dimensional array form before I can load it into a data frame. Have you guys worked on Python metrics, like one-dimensional array, two-dimensional array?
Yes, sir.
Yes.
Right? So now it will make more sense that why I cannot convert this RDD into data frame and why I need this, because this is more of a two-dimensional structure, and a table is always a two-dimensional structure. So now it's like this is the first row, this is the second row, and both of them having only single columns. Okay, so Madhu, Harish, is it done? Okay. Anyone who is having any doubt, or can I move ahead? That why I converted this RDD into this form, and then what is the struct type? So please quickly ping me if I can move ahead.
So it's in this case, now it's working. But like if we have the error, the array which is previously there, like values 1, 2, and that.
It will work in that also.
Not working.
No, sir. It's showing error.
Okay, check. Let's say, let's take a smaller one. Huh? One second. Are you getting the error here only?
Yes, sir. On R2 color.
Yes, sir.
Yes, sir. On R2.
Okay. See, let's check. One second. What happens is, if you use the split function, why it's not working in this case is because remember I told you, when you use lambda on x, what is x? Can anyone tell me? What will be the value of x? What will be the value of x? It will be 1.
1.
Then it will be 2, then it will be 3, right? It will be like that onwards, right? Means it's an integer. And we cannot use a split function on an integer.
Yes, sir.
Right? So this being an integer, you cannot do a split on it. So if you want to solve it, what you can do, let me tell you. I'm just trying, okay? This. Understand, guys, understand everything logically, that each of these elements are what? These are integer values. On integer, how can you split an integer? Because split is a string function. So what I did, for every input integer, I first converted into a string and then run a split function, and I got this form. Now it will work. Please check it and tell me.
If in case I want to sum values in this column, then what we will do, sir?
Why you want to sum, first of all?
Like some similar values and similar IDs values.
No. Tell me the proper problem statement.
Like in this column, we want to add some three rows, like same similar IDs.
You want to add similar IDs, as in why? Because these are employee IDs. Why you want to add employee?
Not this column, sir. Like some of salaries.
Okay. Let's say there are salaries. Like
Yeah.
1, 2, 3, 4 represent salaries. So you want to add only 1 and 2 and 3 and 4.
Yes, sir.
But why you want to do that? Because these are salaries for 4 different people, right? How there is no logic that you can write to add only the 1 and 2 and 3 and 4. Because how will you do that?
But if in case I want add in 4 rows, because it's a string now, that's why I'm asking.
No. See, the purpose here is different. Why we did to string and this format is because we have to load it into a data frame. Right? Because we have to load it into a data frame, and then on that data frame, whatever you want to do, you do. But if you don't want the data frame work, if you're happy with this, you do the RDD operations, no? The actions and transformations that you have. If you
Yes, sir.
if you just want to stay with this, stay with this. You don't need to cast it into a string to add it and all. Are you getting my point? Why we are doing this is just because we have to load it into a data frame. But what you are asking me is something that you want to do on RDD, like adding the first two elements or the last two elements of RDD.
Yes, sir.
So then that's a different question altogether. Are you getting my point? Because I will not do this string conversion if I would not have to load it into data frame. If you just want to add the elements, you just add them using RDD actions and transformations.
Yes, I get it.
If you remember in the last class what we did, if you have to do anything on RDD level, you have to use the map functions, filter functions and all, no?
Got it, sir. Got it.
Okay. So don't get confused that Rahul, since you have converted this into string, then I will not be able to add these values. I converted into string because my purpose was different. But now you are saying, Rahul, I want to add the first two elements and the next two elements or whatever. Then what you have to do? Like say r2.map, then you have to use some lambda expression, pass x into it. And let's say you want to do x plus 2. Let's say you want to increment every value by 2. I'm just telling you that. So every value will be incremented by 2. But if you want to add these values directly, it won't be possible because it is like you need a key on which you can do group by. If you say 1, 2, 3 and 4, you want to add these two values and you want to add these two values, right? This is what you want. Then you need a common key, like let's say A, and here you have B and B. You have to do something like that so that it's like a table, column A, column B. You group by this column and add these two values. You group by this and add these values. So unless you don't have any common key, how will system know that it needs to add these two and add these two? System won't be able to do that without having another column which will have a key column on which you group by. Are you getting my point?
Yes, sir.
So on this data, you cannot do what you are asking because you don't have a key column. Because you need a key column and then you have to do group by. So here that cannot be done. You cannot add the first two and the next two because there is no key column. Okay. But even I can do that, but that will become very complicated way. I can do that also, but it will become a bit complicated. However, you have to use these kinds of lambda expressions and map, flat map functions, filter functions and all to do that kind of operations. It is doable, but it will be a bit complicated because I don't have directly a key column. I have to create a dummy key column based on some program, and I can do it, Madhu, still, but it will be complicated. Okay, just because you're asking, what you can do is something like this. I'm just telling you that currently what I'm doing, for every input value, I am outputting the value with a hard-coded one, like 1 with 1, 2 with 1, 3 with 1, 4 with 1. Now in this case, key column is this. So if I group by key, I can now add all of these 4 values. 1 plus 2 plus 3 plus 4, provided I group by this key column. So I have to introduce a key column. And now what you want, Madhu, is you are saying, Rahul, let's say put 1 and 1 here, and Madhu, you have to introduce 2 here, 2 and 2 here, Madhu. So that when you group by, these 2 keys are same, so these 2 values will be added, and these 2 keys are same, so only these 2 values will be added. But then you have to, instead of throwing 1, you have to throw 2 also for these 2 records, which will need some programming. Madhu, are you getting my point?
Yeah, sir. Yes.
This is the answer to your question. So you don't need to worry about why I did that string wala thing. The purpose for that was different. Okay. 1 second, guys. So then you have to use this group by on RDD, Madhu. Like you do group by on a table, you have to do group by on an RDD, but then you have to learn these different functions. Group by, and there is aggregate by, there are a lot of functions. Huh? So you can read about these. There are different aggregate options in RDD also. But I don't want you guys to go into RDD that much because then you have to learn so many different functions. Group by function, aggregate by function. Rather convert an RDD into a data frame. And on top of that data frame, you create a table and do simple work. Otherwise, it will be difficult to remember all these functions. RDD is all about these functions, aggregate, group by, different functions. Okay. Madhu, does that answers the point?
Yes, sir.
Okay. So you have to stick with the RDD only for what you are asking. This thing we did for the table wala work. Okay. So guys, if it is done for all of you, I'll quickly take another 20 minutes to do the machine learning, and then tomorrow we'll continue. So let's move into the next topic.
Sir, sir, can you share this whole notebook?
I'll share it. I'll share it after the class.
Like when I have doubts, like we have to run this collect command after this whole initializing this what we use this split. Yeah.
No. This is just to see the data. Collect is only to see the data. If you don't want to see the data, leave it. Don't do it.
Okay.
Collect is always just to see
And
the
also,
data.
also, sir, like you have used one like lambda or something. This for command. For loop, yes, sir. In the some next commands like check. So yeah, so,
This.
yes, sir. Yeah, this one. So we have to use this also, like.
No, you don't need to use this.
Okay.
I didn't told you this. No, leave it.
Yes. Like I'm getting error, so that's why I'm asking.
No. If you're getting any error, you can share me that screenshot and I'll discuss with you after the class.
Okay, sir.
Only if you have any doubts why it's not coming, I can help you. Copy. So I am sharing my notebook link. So Madhu's point was related and relevant, so that's why I discussed this point. But yeah, any specific errors we can discuss later. Okay, guys, Spark may look easy sometimes or difficult sometimes because it's really not that easy. So please go through it. So now what we are moving into the last topic, which is Spark. Again, ecosystem, let's go. Okay. So far we have done Spark core, which is like RDD. We have done Spark SQL, which is data frame. We have even seen the relationship between the two, like how to convert an RDD into data frame. We took one example. We saw that. We know that there is a streaming layer also out of scope for us. We have machine learning library, which we will do now. GraphX, which is again out of scope for graphical data processing. So now the only topic left for us is machine learning, MLlib. So now we are going into the Spark's machine learning thing. Spark contains Spark core, SQL, streaming, MLlib, and graphics. So Spark MLlib. So when we talk about Spark ML or machine learning using Spark, so you will see two things: Spark ML lib and Spark ML. So guys, I'll tell you, in Spark there are two ways to do machine learning. One is the ML lib, which is older way, and ML, which is the newer way. ML lib used to support RDD. So if you want to do machine learning using RDDs, you use ML lib, which is not a good thing. So we will be doing Spark ML, which is machine learning using data frames. This is machine learning using RDDs. Okay, so remember, we are not doing Spark ML lib, we are doing Spark ML. So we are not doing RDD, we are doing data frames. Any question before I move ahead?
No, sir.
Okay. Do any one of you now see, because we started with machine learning today, I would ask you a few questions. Okay. Okay. How you used to store your final output? Means, are you aware about the model files? Have you heard about pickle files, model files, anything like that?
No, sir.
It's a little bit of job lib. That's it.
What? Little bit of
Job lib.
job lib. What is a job lib?
It is used for deploying the project. Maybe we have to load the project into some new file.
Okay. So see. Okay. So now I told you in Spark, we are not doing ML lib, rather we are doing Spark ML. So we need to understand what is ML pipeline. Do anyone understand what is ML pipeline? See, what is a machine learning pipeline? We have to create a machine learning pipeline. That is, read the data, do the feature engineering, do the missing value imputation, as in maybe doing scaling, then training the model, then evaluating the model, then deploying the model. So what is a machine learning pipeline? It's a pipeline of all these steps. Remember, very, very important. In today's world, companies say, do you know ML pipeline? So that's about machine learning pipeline. You read the data, you do missing value imputation, feature scaling, anything of that sort. Then you do model train, model test, and model deploy. This is a machine learning pipeline. This entire pipeline needs to be saved in form of some output file, which is known as a model file, a model file or a pickle file, or maybe job lib also. You can use job lib also. That is another way. So read about it a bit. What is ML pipeline? What is model file? What is pickle file? We'll talk about these things. What you see here on my screen is a pipeline. See, data ingestion, data cleaning and transformation, model training, test and validation, and deployment. So in a Spark, you are doing machine learning. Again, using RDDs, data frames, data sets, whatever, you can do that. But here you need to understand what is a machine learning pipeline, the most important thing. In today's world, everything is machine learning pipeline. We will see how to build a pipeline. So here what you can see on my screen is, this is also machine learning pipeline, but bit advanced, where you have the data. On that data, what you are doing, you are passing that data into 3 different machine learning pipelines. One pipeline this, another pipeline this, another pipeline this. That means the same data, sometimes you want to pass through a random forest, a logistic regression, and some other classifier, and you want to compare all these 3 models and see which one is better. Or you can use an ensemble of these 3 to do the prediction. So sometimes it may happen that you will have a single pipeline of the model. Sometimes you may be using multiple model pipelines. We will see that multiple model pipelines, like first model, second model, third model, so that you can compare which is better using k-fold cross validation and all. You can check which is better and select the right model for you. So this is all what Spark machine learning library provides you. But machine learning pipeline is not a new concept. Even in sklearn also we used to have pipelines. Even in sklearn, from sklearn.pipeline, you can import a pipeline and you can create a model pipeline. Pipeline will have multiple steps: data cleaning, data imputation. Okay, so every pipeline, let me show you today at a very high level. What we are doing here is, see, I'm saying, hey, sklearn, please create a pipeline. वो कहता है, okay, I'll create a pipeline. So pipeline needs to have some steps. Step 1, step 2. Oh, sorry, this is step 1. This step 2. So there are 2 steps. One of the step is standard scalar. So that standard scalar is coming. Another is the model, support vector machine, your SVC model. So you create a pipeline here. Here you create a pipeline, right? That pipeline will contain 2 steps. Now, once you have the pipeline ready, see what you are doing. You are fitting the pipeline. You are not fitting the model. I'll tell you what. Then you are scoring the pipeline. You're not scoring the model. So it's a very easy thing. Guys, see, normally what you do, you create a standard scalar. You pass the data and you get the scaled data as output, right? Then on scaled data, you then do something. Let's say you do missing value imputation. Then you get the correct data. Then you train the model. And then you get the trained model. Means every step you were running one by one, right? So far, you were running first step, then you are running second step, you are running third step, right? That is a time consuming process. We don't want that. So rather what we will do, we will create a pipeline. That means we will just create a pipeline saying that this pipeline should do missing value, scaling, and model training. And when you fit this pipeline, it automatically run everything one by one. You don't run every step one by one. You just say, hey, pipeline, can you please run? So pipeline will start its first process, second process, third process. So the entire pipeline will run. You don't need to waste your time. See, normally what happens, let's say when you are running this first step, it takes 10 minutes, you are waiting for 10 minutes. Then you were running this, you are waiting for another 10 minutes to run that another process or another step. But when you run a pipeline, you just run the pipeline and go home. And after half an hour, you come back, all the things will be done. So you are not running the scalar separately, the classifier separately, whatever. Everything is running as a single entity, a single pipeline. Guys, are you getting my point?
Sir, but there's an error in between, then what will happen?
So that's what definitely you create a pipeline only once everything is tested.
Okay.
Definitely, you are absolutely correct. Because if anything fails, you will get to know that after half an hour, because you thought that it will take half an hour and you come back after half an hour. So definitely you make sure first everything is running fine, then only you create the pipeline. No? Let's say you are using standard scalar, but the data that you have does not support standard scalar. So definitely you don't use standard scalar, you will use some other scalar, maybe min-max scalar. Getting my point?
Yes, sir.
Guys, any question on this? What is an ML pipeline?
All like if there are 3 pipelines, so all 3 will be run at a time or one by one? It is parallelly, so I guess
They can run parallelly.
yes, sir.
That's what the benefit of distributed computing, Hadoop or Spark kind of systems.
But we can't analyze what is happening in this pipeline, like if what is impacting more. Like if I've chosen missing values as a mean, and in the other pipeline I was using as a missing values change with the median. So that whole thing will be comes as an output, no? Output end, not right in between. We cannot analyze it, what is happening or how things are getting.
Very good, very good. 1 second. There are a lot of different type of ML pipelines. 1 second. I'll take simple one only. So let's say this is your ML pipeline in which you load the data. Then you are doing some transformation, estimation, evaluation, right? This entire pipeline was running for you, right? But definitely you can see that system or anything only once the pipeline is complete. But let's say here you have DF1, Pankaj, and after you did some feature extraction, you get a new DF2, right? You do some missing value imputation, you get DF2. So these data frames, so anyways will be there in the system, no? So you can check the data which is in DF1 and check what is in DF2 and see what is the difference between the two. Because model will be run end to end, but these data frames will be created now while the pipeline was running. So after the pipeline is complete, these data frames are not getting killed or truncated, right? Data frames will still be there, right?
Okay.
So if you have done some missing value imputation on DF1, you will get DF2. So you can check that column na, in DF2, that what are the missing values, whether the missing values are as per my requirements or not. So and you run pipeline once, but that does not mean that you cannot run pipeline again by changing your system. Let's say initially when you run the machine learning pipeline, you ran it with missing value imputation as mean value, but you are not happy with the output. So now before you run the pipeline again, you change your logic for missing value imputation and run it again and see whether the output is coming good or not.
Okay.
So for example, let me take this. So what I am telling you guys here is, see, what I am telling all of you is this thing. that this is the pipeline that I'm creating, guys. See, I'm saying a pipeline which contains the step 1, which is a standard scalar, and the step 2, which is a SVC model, right? Let's say this is the pipeline created. And then I fit the pipeline, right? And then I score the pipeline, means checking the score, which is 0.88. And let's say you are not happy with it. So what you can do, even you can change it to logistic regression and put a logistic regression model here. Getting my point? But here you have to import the logistic regression also from sklearn dot, I don't know what it is. It is a linear models or what? sklearn
Yes, sir.
dot
Linear model. Linear model.
Import logistic regression, right? Then what you need to do? You definitely need to create an object of logistic regression. LR equals to logistic regression like this. Getting my point? And then you will pass that LR here. Or you can directly pass this also. If you don't want to do this, you pass this logistic regression here as is, if you don't want to do it. And now when you run it, let's say your score comes to 91 or 92, you'll say, oh, now logistic regression model is better than support vector machine. But let's say now you say, okay, now I'm fine that instead of SVC I will use logistic regression. But you say in logistic regression, I need to do hyperparameter tuning. So let's say you now modify this pipeline, and in logistic regression you will say, let's say learning rate. Let's say you are changing learning rate, which is alpha, equals to say 0.02. You are just increasing the learning rate value. So this is also a ML pipeline. This is also ML pipeline. But what I am saying, guys, is let's say after changing the value to alpha, it comes to 98. So no one is stopping you to modify your pipeline, no? Once it's built. You create a pipeline, you will check it. You are happy or not depends upon, then you try to do some hyperparameter tuning, run that pipeline again. So, but the only benefit here is that you are running the entire pipeline. You're not running first standard scalar dot fit and then LR dot fit. Everything is run automatically. Guys, are you getting my point?
Yes, sir.
Yes, sir.
This may be a new concept for you, but please take some time to comprehend it. That in machine learning, in today's world, we always talk about building pipelines, ML pipelines. Those ML pipelines may have different steps. It may happen that here you have one more step after standard scalar, but here you may have only 2 steps. It depends how big or complex your pipeline is. And within pipeline, whether you are using a model with its default hyperparameters or you are modifying some hyperparameters. Okay, so the thing is, we do pipeline dot fit and pipeline dot you can say score, which was like predict dot fit dot predict. So dot fit dot score. So here you are using the test data. So you will pass the train and test data to the pipeline, not to the individual step. So instead of running individual steps one by one, you are running a pipeline and just getting relaxed. But it may happen that initially your pipeline will fail maybe at any of the step. So you have to fix it, as someone was asking. Yes, your pipeline can fail at the first step or at the second step because of some data incompatibility. Let's say this standard scalar needs integer, you are passing it string, it may fail. So you have to take care of all those kind of things. And then only you will have a final pipeline which is ready. Here, so he's just using make classification to generate dummy data. Nothing here. So a lot of pre-processing can be done. Okay. Any question on this, or can I move ahead? So guys, read about even sklearn. Try to do even in sklearn also what is a pipeline, because we will be not using sklearn. We won't be using sklearn, because sklearn is not distributed, right? So just to tell you, we will be using the package. So guys, we will be using PySpark package, PySpark.ml. There is a PySpark.ml lib also. ML lib is for RDD. We are not using that. PySpark.ml is for data frames. So we are using, see the pipeline here. We are using feature engineering. This string indexer is like one hot encoder or label encoder. Okay, so we will be talking about these tomorrow, not today. But I'm just giving you a feeling of the system, that it is nothing different. From PySpark.ml.classification, we will import logistic regression. We will say logistic regression.fit, logistic regression.predict. Okay, so we will be doing all those things like train test split. We will be doing the data split into 70%, 30% using random state or a seed. We'll talk about this tomorrow. We are using a logistic regression model. We are passing some hyperparameters. Like, remember, you have, can anyone tell me what is this parameter? Max iter, what is this? You have something known as iteration in sklearn. What is that?
Number of iterations.
What is iteration? What do I mean by 10 iterations here?
That means repetitions, like how many times you want to repeat.
Repeat what? How many times I want to repeat what? The training of the model or the testing of the model?
Training of the model.
So why you guys are not telling it? So maximum iteration is your model will be trained through 10 cycles. Right? 10 cycles. It will go through the 10 cycles of training. Like first cycle, it will go through, it will get some accuracy. Then it will go through another cycle, its accuracy will improve. So the more the iterations, the more better the accuracy. But it is not always the case. Okay, you should not have very high number of iterations, because definitely model will learn with each iteration, but there should be an optimal number of iterations. Then I'm doing .fit, .predict. Here .transform is .predict. Then we have to check RMSE, MSE values. We are checking the RMSE, MSE of the model or the accuracy of the model. 89% accurate. Area under the curve, right? ROC, AUC curve. So we talk about area under the curve. So it's all same. We can use k-fold cross validation and all to do model tuning. So everything is there. Just the packages are different, guys. So what I want you to at least revise your concepts before tomorrow's class on the machine learning. I'll ask you a few questions before we go into the modeling. Okay. So can anyone tell me difference between bagging and boosting?
So
Okay, wait. Adhyan, go ahead.
So bagging is basically taking an average of all the models or all the keys we have run, and boosting is it's gradient boosting, in which it learns from the errors it showed.
Errors showed by what?
So by the model misclassifications we get from the confusion matrix. So the next time we run the model, it more focuses on the errors.
Okay, Pankaj, would you like to go ahead?
So like what I remember, like it all related to this what is taking in the training, like the fields or the records. So random fields in if we taking the random fields, it is bagging, and the boosting it is taking both random fields and records both.
No. That you explained about the random forest and bagging. You talked about bagging and random forest, where random forest is an example of bagging only, but boosting is something different, as Adhyan said. But Adhyan was also, I would say, partially correct. I need more explanation, as in boosting, you run models in a sequence. First model, second model, third model, right? In bagging, models are run in parallel. Right, Adhyan?
Yes, sir.
Okay. So you need to understand these things, okay? Arushi, can you tell me few hyperparameters related to random forest?
So like the criteria,
What is the meaning of criteria?
like what we use, the Gini coefficient or the entropy.
Okay.
Or the-
Split criteria, huh?
Yes.
Other
Then
than that,
we check the maximum max depth.
max depth, huh?
Yes. Then we check the split, like the data split, like node split.
Min splits and min buckets.
Yes, sir. Yes, sir. Min split and bucket.
So don't you think everything that you are telling is about a decision tree?
So like there are n estimates, like they are also used in the random forest. Except for that, we use n estimators, like the number of trees we use.
Correct. Number of estimators, right? Which
Yes.
is more related to this. Anything other than that?
I don't remember. Like I remember this movie right now.
Okay. Can anyone tell me difference between GBM and XGBoost? Guys, what is difference between GBM and XGBoost?
GBM is gradient boosting,
Uh-huh.
and in XGBoost, it's like
It's extreme gradient boosting, huh?
no. So it's better than GBM, I guess.
No. Never give this answer.
Sir, I think both are almost the same except one or two factors. I'm not remembering them. But I think GVM is much faster than XGBoost.
So learning
Although
rate
they,
is one of the factor, I guess.
Okay. Why learning rate? I can change learning rate in both the models. Learning rate is just a hyperparameter, no?
Yes, sir.
Then how is it different? Means it's good that you are answering. Okay, very good. But yeah, why XGBoost is known as extreme? What is the meaning of this extreme in that? Huh? What is huh? Yes.
Like it controls overfitting,
Yes. How?
execution.
How?
So as it use more regularized model, no?
More regularized. What do you mean by regularization?
So actually we need to memorize all the things.
No, it's good. It's good. At least like you're saying regularized, which is good. But what is regularization, right? Regularization is a process to avoid overfitting. There are two kind of regularization, ridge and lasso. Have you heard about ridge and lasso?
Yes, reach.
Yes.
Ridge regression, lasso regression, right?
Yes.
Yes.
Yeah. Okay. No problem. Yukti, can you tell me in logistic regression what is the cost function?
The maximum likelihood estimation.
Very good. MLE is a process. It's not a cost function.
Yes.
Maximum likelihood estimation is the estimating. No, wait. Maximum likelihood estimation. It is the estimation of maximum likelihood of happening any event, right? So what is the cost function?
Binary cross entropy.
Yes, very good. Binary cross entropy or multi-class cross entropy?
Yes, sir.
Okay. Sanjana, can you tell me what is difference between bias and variance?
Sir, I don't remember.
Okay. Saket? Bias versus variance. There is a very famous chart for that. Bias versus variance chart. Okay. Okay, Saket. You are there? Okay, leave it. Cheryl, can you tell me for a overfitting model what is higher, bias or variance? And for underfit model, which is higher, bias or variance? Cheryl? Okay.
Sir, there is a low variance for underfitting.
Low variance for underfitting. Why?
Mm,
Can you elaborate?
let me try, sir.
Absolutely.
Variance.
What do you mean by variance? See, variance means with any new data, any slight new data, models accuracies starts to change drastically. It's varying. Variance means any slightly new data that you ask the model, even if you change the trained data a bit, the model start to behave abruptly. So variance is higher. Why? Because it was overfitted on a particular data set.
Yes, sir.
And what is underfitting is like you don't know about the system. You don't get the enough data that you are supposed to get, right? That's why you are underfit.
Miss, we very less amount of data for fitting model.
Okay.
Means underfitting.
Have you seen this chart? All of you must have seen this chart, right?
Yes, sir.
Okay. One second, guys. Just a second, guys. It is raining, so I had to do something. Yeah, so that's fine. So if you see this graph, right? So in the variance increase section, you are getting the overfitting zone, and this is the underfitting zone, which is the bias. Something in between is what we look for, right? So please go through these charts. Sometimes in interview they ask you to explain this chart, and also this chart. Both of these charts are asked in interviews to explain. Sometimes they give you MCQ and ask you questions on this. So please read about it. Okay. Am I audible?
Yes,
okay,
sir.
Okay, Cheryl, I got your answer. Okay. Let's 1 second. Okay, so who is there? Lokesh, can you explain me something about PCA model? Lokesh. Madhu. Have you heard about PCA, Principal Component Analysis?
Yes, sir. It's a
Yes, sir.
Yeah, Madhu.
size,
Mhm.
their size reduction algorithm.
What size?
Like data.
Data to contain rows and columns. So what it reduces, rows or columns?
Columns. I think.
So
It's
it's dimensionality reduction model, no?
yeah, sir. It shows the best
Components. Means
Correct.
in our data there are so many columns or so many components. Yeah, using PCA technique we can extract very important means principal component and model create a model on this component.
So Pratik, can you tell me, let's say my model contains feature A, B, C, and D and E.
Okay.
So if I run PCA on top of it, what can be the output?
There is a there is a no specific feature A, B, C, D. There is a they using PC they give some operations like A plus B,
Very
A
good, very good.
multiply with
That's it.
B, like
That's
that.
it. That's it. I got it. Yeah. So PCA is never going to give you output like okay, A and B are better. It's going to give you some principal component like PC1, PC2, where PC1 can be A plus B, right? PC2 can be A plus say 0.3 times of B plus 0.5 times of C, like that. Correct?
Yes, sir.
Okay, good. That is the most important point. Huh? Okay. Okay,
Yes,
guys.
sir, it's very useful.
Yes. So what I want you to please revise your machine learning concepts, and tomorrow we will be implementing this machine learning using the PySpark's ML package. We won't be using sklearn. Okay, we don't use sklearn here. We use PySpark. Okay.
Okay.
As I told you, we will be using here PySparks.
Sir, there is a one day enough for machine learning with PySpark.
It is, yeah. Tomorrow we will be doing that, like how to see the charts and all. Today was also there, but we had some other things to discuss. So tomorrow also we will be doing it.
Okay.
How to build these decision trees and all. Okay, guys. So please study what I have told you. Spark ML versus MLlib. PySpark has its own machine learning library. Read about it. Okay. So thanks all. We'll connect
Thank you so
tomorrow.
much, sir.
Okay, for machine learning. Please do that RDT to data frame conversion if someone hasn't done that. We put good time on that. Huh?
Okay, sir.
Okay. Okay, guys. Thank you. Thanks, everyone.
Thank you so much, sir.